In today's tutorial, I'm going to show you how to match a virtual camera with a real-world one in Blender. And I've actually done this tutorial before fairly recently, but that tutorial had some glitches and a couple of kind of silly problems with it. So I'm going to try to redo that tutorial maybe a little more efficiently. So we started off with a default cube here, just like we always do, but we're actually going to kind of cut to the real world here for a second because we've got our virtual camera. But we don't know basically enough information yet. We don't have a photograph that we're trying to match, and so we don't have some parameters. So let's cut out for a second, and we'll come back here after we've taken our photograph. So in order to match a camera, a virtual Blender camera with a real-world camera, we need to know a few things about, well, it helps a lot anyway, to know a few things about where our camera was and what it was photographing. Specifically, we need to know three things. We need to have an object of a fixed size, so I've measured out 1 meter from corner to corner and corner to corner. I've got 1 meter square here marked out on my garage door. I've also got a center mark here so that I know how high my camera needs to be, and I've got a monopod that's adjusted pretty close to that height. And then I need to know how far my camera is from the object. So if you look down on the floor here, I've got a 2 meter mark marked out in tape, and basically all I need to do is I just need to know those dimensions, and then I'm going to come over here and I'm going to try to center up as best I can on that square and try to make sure there's not a lot of tilt to my camera, and then just take my photograph. And then we're ready to bring that photograph into Blender and try to match it with our camera. Okay, now that we've got our photograph and we have our 3 parameters, and I'm just gonna, just for the sake of argument, and clarity, I'm going to bring up a text editor over here and list those once again. So we need a subject of known dimensions. We need to know the height of our camera, and we need to know the distance of our camera from the subject. So now that we know all of those, we're going to model them. So we've got our default cube. Let's go to an orthographic viewport, so 5 on the number pad and then 7. I'm going to look at the top. And our object of known dimensions was 1 meter by 1 meter by 1 meter. You can see from our little properties panel here, you can open it by pressing N, that the dimensions of this cube are 2 meters by 2 meters by 2 meters. So I'm just going to change that, 1 by 1 by 1. And also I want the very front of this to be at 0 in the y-axis, so right along the x-axis there. It'll just show up basically flat, and the reason for that is that that's the point from which I'm going to be calculating my camera's position, and so I don't want it to be a ½ meter off. So right now it's centered on y, and I'm going to change it to, good grief, minus 0.5. And actually, sorry, I need to go the other way, 0.5 meters. Okay, now I've got my camera. I need to change its position. So it's kind of in this sort of arbitrary position over here. First of all, let's zero out the X. And the camera's got, you know, a lot of shape to it here. You should know that the point from which we're actually viewing is this point at the back of the camera. I mean, you can go into your camera settings and you know, you can change the size of it all over the place, but it doesn't change the view that the camera has. So I'm just going to point out that that's the point that we're trying to line up there. So 0 meters, and we know we were 2 meters from our subject, so I'm going to put -2 into the y axis, and z, if you look at our Z position, we're way too high. I'm going to zero that out as well, because we tried to be right at the height of the midpoint of our 1 meter subject square. So we're going to try to, that's why our the Z of our cube is at 0 and the Z of our camera is at 0. They should be centered with each other. Now let's get rid of this kind of weird rotation that they've got going here. Oops. X is going to be probably 90 degrees, and Z we're going to 0 out. Okay, so that's our setup now, and that actually should match our real world setup pretty well. And you can see we can see the cube reasonably well there. We're going to mess that up really bad here. So also we need to resize the aspect ratio of our camera. So our camera is currently at a 16:9 aspect, because you can see on our render settings, our render output settings, it's set to render 1920 by 1080, which is just a full HD video frame size. So our camera shoots 4032 by 3024 pixel images, and I know that because if I go into the properties on the picture that we took, you can see those dimensions right there. So that's kind of handy to know that you can look that up. You can see that the shape of our frame has changed, and it's going to be more like the picture that we actually took. So let's put an image background into our camera. So I've got this background images checkbox. I can add an image here and click on open. Let's go to our Dropbox, and there's our image. Okay, and it's showing up in the background. We can kind of put it in front if we want to be able to see things a little better, see the image through our cube. All right, and now we need to start matching the camera's internal dimensions. So we've got two things that we're looking at basically. We've got the focal length of the camera, and also, I'm going to collapse this just to clean things up. We've got our sensor size, and right now the sensor size is set to 36 millimeters wide. That's the size of a full frame camera, which an iPhone, like I took this picture on, has a much smaller sensor. So we need to be able to look up that information, and unfortunately I took this picture on an iPhone X, which is like the iPhone that time forgot. Nobody has any information about it, but it turns out it's, I think, from Googling, the same as an iPhone 8 Plus. So I Googled that, and I can see that my sensor size should be 4.88 millimeters wide, and these guys are saying that the lens is a 29 to 57 millimeter equivalent. Now that's going to complicate things a little bit, but we can work through it. So first of all, I'm going to change my sensor size. 36 millimeters, and we know it needs to probably be 4.8. Can we really trust that number? I'm not sure. And just to be weird, I'm going to make sure that Blender knows that that's the horizontal width of the sensor. And you can see that everything went kind of gray here. That's because my cube got really huge, because we shrunk the sensor size that our 50 millimeter virtual lens here is projecting an image onto. So they're saying 29 millimeters. I didn't zoom at all on my iPhone, and that's because I wanted to be able to predict what the focal length should be. If I did some arbitrary finger spread to zoom in, then I'd have no idea what that focal length should be. So we're zoomed out all the way. You can see the cube got a little smaller, a little bit of a wider angle there, but it's still really not matching up at all. Okay, and that's because, again, you can see that this is a 29 to 57 millimeter equivalent. In other words, that's not the actual focal length. And a little further Googling reveals that the iPhone X, the 8 Plus, and the X, they should have what's called a crop factor of 7.21. So basically I can take that 29 millimeters and divide that by 7.21, and that gives me a focal length of about 4, which is kind of what I've heard. I've heard 3.99, and honestly probably can't trust any of those numbers, but let's just put 4 in. Okay, and you can see that that has produced a much closer result. Our cube, our meter cube, is now a lot closer to the size of our meters square that we were photographing. It's not quite lined up, and that's on me. You know, that's due to my twisting, and you know, in an ideal situation I'd really measure things out and get things at a perfect right angle, but you know, we're not building a piano here, we're just making a precision 3D model. So basically I can either move the cube or I can move the camera around, but neither of them should ever be moved in Y during this process. And I should probably emphasize that we're not really making a camera matched picture here yet. All we're doing is we're building an accurate model of the camera that we're going to use. So again, to match those up, I can move either of these, but neither of them can be moved in Y because that's a known dimension. We measured that. We know we're right there. So I'm going to move the camera. I'm just going to tap GX and move it really carefully over here, and then GZ. I'll hold down Shift if I need a finer movement, and I think I'm going to trust the top more than the bottom in this instance. And you can see that we're pretty close with that 4. Again, if I have to trust one of these, the sensor width or the focal length, I think I'll trust the sensor width a little more. And I'm going to start playing with the focal length a little. I'm going to hold down Shift so that my increments are kind of small, and you know, even those increments seem too big, so I'm going to type something. 3.98. Let's try that. And that's even closer. Let's try 3.97. And that's starting to look really good horizontally here from the top. Again, that's probably, I just kind of have to decide which side I'm going to trust. So let's move our camera again a little bit. GX, hold down Shift to make our movements really fine. GZ. And that looks pretty good. And vertically, this one's showing as reasonably close. And horizontally, this one's reasonably close. So I'm going to call that equivalent. So we're going to say 3.97 millimeters, 4.8 millimeters, and that's going to be our camera basically. So basically I can just write those attributes down: 3.97 millimeter focal length and a 4.8 millimeter sensor, and I can save that forever. Or, you know, I can create a new preset here. I can call this iPhone X, and I can call that up again. So I've got my camera modeled. Should be pretty accurate. So let's throw a photograph in there. I'm going to turn off my background image, and I'm going to delete my default cube, and I'm going to make myself what's called a camera sweep. A sweep is basically a photography tool. It's a piece of photography equipment, and it's kind of something you build into a room usually, or hangs down from a wall. And it's basically a background with no corners, so that it looks seamless, so you don't have hard shadows. And a sweep's really easy to make in Blender. Just gonna Shift A, create a plane, scale it up about 50 times, move it so that it's totally in front of my camera, and then I'm going to tab into edit mode and extrude the back in Z. Let's look through our camera. This is probably a good time to change the Z position of my camera, because it's still at 0, which means it's set on the ground basically. And when I photograph, my camera's about 1.75 meters in the air, so I'm just going to change the Z position of my camera to 1.75, and from there I can widen, scale in X, widen my sweep to kind of take up a little more space, and now we'll smooth it out with a subdivision surface modifier. So there's my subsurf. I'm going to change my viewport levels up to 2 and tab into edit mode. I'm going to use a couple of loop cuts to sharpen my corners here. Just a little. Don't need them super sharp. And that's probably good. We'll shade smooth. And there's our cornerless sweep. Alright, I'm going to change my light into a sun instead of a spot lamp, because a sun is Its position doesn't matter, and it has no fall off, no decay. We'll have to turn the strength way down so that we don't blow everything out, but basically that's going to kind of help me in illuminating this background. So let's look through this. I'm going to repeat, as always, I'm in the cycles renderer because it's going to deal with shadows and light in a more accurate way. And I'm going to put a material onto this sweep. So we'll just create a new material here. We'll call this sweep BG. And my base color is going to be... Alright, so I'm going to open a new image here, and it's going to be an image that I took in advance of this tutorial. And let's have a look at a rendered view, and you can see that it's kind of messy. Everything's showing up on the floor, the sky's really stretched. That's because of the way I extruded my sweep, and that's not really useful at all. So having already split out my window here, I'm going to do another split really quickly, and let's just go to a shader editor. We're going to play with the texture coordinates on this. So I'm going to create a new input for texture coordinates for this image, and you know, we often use the generated or UV image coordinates, but in this instance I'm just going to use the window, plug that into the vector, and basically what that does is that says, well, let's just stretch the image to not be distorted and look directly at whatever the camera is. So if I actually exit the camera view, if by camera we mean just whatever I'm looking at, you can see that even as I tumble my view, that image is still facing me, and it is the size that would fill my screen. So it's really kind of a funny looking view, but through the camera it looks perfect. And now let's change our sun lamp here, because if you look from a side view you can see it's actually casting a shadow on the back of that sweep. So let's aim it toward the sweep so it's evenly lit. And the sun was kind of behind me and above me a little bit for this image. It was about 1:30 in the afternoon, pretty high in the sky. So that ought to light our image fairly evenly. I might turn the lamp down just a little, actually. We can go as low as, well, I'm going to say 1's a little dark. Let's go with 2. Okay, so there's our camera view. And from here I can just stick something in, and it will actually look pretty good, because let's select our sweep and tab into edit mode. You can see that the corner of it's right here about where the geometry depicted in this photograph turns anyway. So let's put an object in there. I'm just going to create a UV sphere, and this is just a typical 2-meter sphere, and you can see that already it's casting a shadow on the ground, and it's receiving colored reflections from the ground, which is pretty cool. So let's shade that smooth and just play with its shader really quick. We'll just put a sphere shader onto it, and I'm going to make it really metallic and turn its roughness way down, and you can see that it is actually reflecting the ground around it as it should, although once you get back here there's no longer a sweep for it to reflect. But you know, I can even go into my world settings, and I can click on this color, and I can eyedropper my blue sky, and that will even create a little bit more of an accurate lighting for this thing, and that already looks pretty good. I'd say its shadow is probably a little too soft. Well, I don't know, this tree has a fairly soft shadow, but the trucks is really hard, and that's kind of the one I'm thinking we should compare to a little more. So let's select our light, go look at some of our light settings. If we want to harden that shadow, in photography we understand that the size of our light source creates softer or harder shadow edges. Size of our light source relative to our subject. But in this instance, for some reason, Blender has put it under angle. So what we really need to do in our sun lamp is we need to reduce the angle value, and you can see that that shadow's starting to harden there, and that's getting a little more similar to what we're seeing with the truck. And we don't want it perfectly hard, but we want it pretty close, and that'll match a little bit better. The other thing I think I'm going to change here is I'm going to go back to this color of blue, and I'm just going to increase the value of my blue that I sampled for the sky. And I'm going to say that that's actually looking pretty good. So I can construct something to sit behind my camera and reflect in the ball here so that it looks a little better. I can use, you know, the same photograph stretched out behind it on a plane, something like that. But that's a little beyond the scope of our tutorial here today. But that's one method of camera matching. It's not the only method. It's certainly not flawless or perfectly useful for every application. But to make a still image that matches an existing photograph, this is a pretty good method. So I hope you enjoyed it. I hope it's helpful, and we'll see you in the next tutorial.